Alright, today we're going to do a lesson on the sine law. And we've been looking at trigonometry in previous videos. I want to point something out. In all the previous videos we did, we looked at triangles like this one. A 90-degree triangle. We used trig ratios to solve it. And sine, cos, and tan, which we can use SOHCAHTOA. And we're able to find this unknown side x. Moving on though, what happens if we get a triangle that looks like the following? What about a triangle that doesn't have a 90-degree angle? Like this one. Triangle ABC, and there's a big 115-degree angle here. You're told this one's 20, and let's say you want to find side A. What we're going to need to use now is, well, actually there's two new laws. There's the sine law, which we're going to focus on in this video, and later on we'll look at a second law called the cosine law. So for today, the sine law is going to help us solve triangles where we do not have a 90-degree angle, and we're looking to find perhaps a side, like A, or even you could find angles with the sine law. The sine law is used on any triangle that doesn't have a 90 degree. So let's have a look at standard triangle here, where you've got vertices A, B, C. They're capital, and those are angles ABC at those vertices. And then angle A, side little a, they're always like associated that way. Capital B for this angle, lowercase b for that side. And similar for angle C and side C. So the sine law is as follows. You can use the sine law to find a side, and it would look like this. So I'm just going to write it out. So there you have it. This is typically how you would write out the sine law if you were looking to find a side, like side A, B, or C. And I'll write it out how we would find an angle. So as you can see, it's basically the same, except we've taken the reciprocal and written it the other way for each ratio. So we flipped them. Okay, and let's write out when we would use the sine law here. Okay, so if you're using the first instance of the sine formula, you'd have to be given two angles and one side to find an unknown side. So for instance, if I hide this, and I only use this portion of the sine law, I could be given angles capital A and B, and I could be given side B, and I could calculate A. Also with the second instance, if I'm given two sides and one angle, I'll be able to find an unknown angle. So what if I, again, hide this, and I'll explain this in a minute with some examples. But if I'm using only these two ratios as part of that sine law there, if I was given two sides, so sides A and B, and I was also given one angle, capital angle B here, well, I would have that known, and that known, and I could solve for capital angle A. Let's show you some examples now. Okay, in example 1, here's the triangle. So they'd like you to find side A, and again, side A will always be opposite capital angle A. Okay, which would mean if this is angle C, there's side C, lowercase. If that's angle B, there's lower side B. So to find side A, we're going to want to use the sine law, because this is not a 90-degree triangle. And it works out that the sine law can be used here. And here's our first shot at it. So I'm just going to write the sine law out and explain. Okay, so there's the sine law. And you'll quickly notice that I've only written two of the ratios. You only ever need two of the ratios to actually solve for an unknown side or even an unknown angle. You don't need C over sine C here. You only ever need 2 or 3. In this case, because I was given angle A, and I want to find side A, I know I need that one. And if you look at angle B, it's known. And the problem is, that's where you put angle B, but we don't have side B, so I'm going to give you a side B. It's 16. And let's substitute everything, and you'll see what I mean. everything is known in this part of the sine law except a. So let's substitute. So a, he's the unknown. We're taking the sine of 56 degrees. And then b, we said is 16. And the sine of b would be the sine of 72. Okay? And the only unknown now is side a. And what you're going to need to do is cross multiply. So we've been doing that a lot. And sine law always uses this. Okay? So I'm actually, all I need to cross multiply is sine 56 into 16. And reason being, if I cross multiply sine 72 into a, I'll just have to divide it out after anyways. So this is how it works out. I'm going to cross multiply sine 56 into 16, and you get 16 times sine 56 degrees, still divided by sine 72 degrees. Alright, so you're ready to calculate, and you can actually use your calculator right away. If you have a good one, you can do this in what I call one shot. So it's 16 times sine 56, and you want to divide that by sine 72. And what do we get? A is 13.9. Okay, let's remember that. For those of you who like to write it out in parts, you can do it that way too. So 16 times, well, what's sine 56? So again, I'm just doing it in parts instead. Let's take a few decimals there, 0.829. So times, I'm just going to put a bracket, 0.829. And then I work out what sine 72 is, 0.951. Okay, and then this is a little longer, but it still works. And you have to do the following. So 16 times 0.829. And I'm just going to get that and divide it by 0.951. And I notice the same answer, 13.9. And you see we've solved the question here. We want to find side A, and we've used the sine law. So each time you want to find a missing side, like side A, as long as you put the unknown variable you want to find up here, in this case it was A, you'll always be able to do this cross multiplication step. It's really clean, really good idea. So try and aim to put your unknown side on the top left on the numerator. Let's try another example. Alright, example 2 has the following triangle. So it's actually labeled as well, RPQ, and we're asked to find angle R. If we take a look at that triangle, there's a 62-degree angle there. I suppose it's possible one of these angles is 90. You're not told that though, so you can't assume that, which means you need to use sine law. So if you remember our sine law, let's go back to what we wrote out. Okay, so there's the sine law, and the first way, we just did an example with this variety here where the side was unknown. Now we're going to find one where we don't know an angle. And the format is sine of angle A over A, sine of angle B over B, and sine of C over C. First thing you would have noticed is there's no A, B, or C. But that doesn't matter. You just have to get the sides matched up. So if you have a triangle with PQR, sine of P over P, sine of Q over Q, sine of R over R. You just make it work for your triangle. Okay, so like I said, our triangle is, there's no A, B, or C. We have P, R, and Q. And here's how we're going to approach this. We want to find angle R, so we're going to write sine of angle R. So that's the unknown. We like to write it as the first thing. And then below R, capital R, you need side R. And of course, we have that. We're trying to find this angle, and we're given this. This is side R. Right? Because capital R is always across or opposite his side, little r. Okay? And now we have to figure out what we're going to equal that to. We've got Q or P to look at. So let's try Q here. And so Q is known. So we can take the sine of q, and then below that, do we have little q? Of course we do, because across from capital Q is side q, like lowercase q. So you can take that ratio. You wouldn't want to use p, because you have absolutely nothing on p. You don't know capital P's angle, and you weren't given his side. Okay, so you've got everything you need. You're trying to find this. You know R, you know capital Q, and you know little q. So now you can put the numbers in and begin solving. So sine R over little r, which is 18, and sine q, so we want to take the sine of 62 degrees, put it over 19. Okay? Again, if you do it this way, you can cross multiply, and you'll only have to send the 18 over top. And the reason you won't send 19 into sine r, because later on you're going to have to divide out 19 from sine r, and why bother doing it? Why bother making extra work for yourself? So I just cross multiply from here into here, provided this is the only unknown. Okay, so let's work that out. Sine r equals 18 times sine 62 degrees over 19. And you're ready to put that in your calculator. Okay, so I'm just going to hit clear. 18 times sine 62. I mean, I can hit equal there, and then I can divide that by 19, and I get 0.836. So sine r is equal to 0.836. Okay, you want at least 3 decimals, maybe more. It can help. 3 is enough because you're going to go with whole number angles. Now, how do we unlock angle r? Well, we've seen this in previous lessons. If we want to unlock r from sine r, we have to take the inverse sine. So sine at the -1 there, that step there is the inverse sine. Okay, that's what we're doing here. And we take the inverse sine of 0.836. Okay, and then on your calculator, you'll have to hit shift sine. Now, some calculators, you actually have to hit like the second button. It depends on your calculator. For mine, I have a shift button. You can see it right there at the top, shift, and then I hit sine. So here we go. Just gonna make some room, and here we go. Shift sine and 0.836, and it comes up with 56.7, which I'm going to round to whole number for an angle. So r is 57 degrees. Okay, and we've solved the question. We were asked to find angle r using the sine law. All right, let's do another example. Example 3, we've got an iceberg that measures 210 meters long, and its base angles are 34 degrees and 57 degrees. What are the lengths of the 2 sloping sides? So take a minute to write this out. Pause the video while you do it and come back. Okay, so this is all the info you're given, including a rough sketch. So this would be the water, and there's your iceberg. So let's put the information in. The iceberg measures 210 meters long, so that's his base. And they give you the base angles, so 34 degrees and 57. It's up to you. You can put 34 here or here, as long as you also put in 57. I'm going to go with 34 degrees and 57 degrees. Now think about it. We're going to model this with a triangle, and all triangles add to 180 degrees. So we actually have the third angle, just with a quick calculation. we know 180. And if we take away the two known angles of 34 and 57, we have that last angle. Ooh, 89 degrees. So right away we can see that this is a triangle that is non-right angle. We cannot use SOHCAHTOA. You're not going to be able to use Pythagorean theorem. You now need to use the sine law. Okay? There's also a cosine law, but today's focus is the sine law. Okay, this is the real world diagram. We're going to kind of use trigonometry now and convert this to a triangle and assign sides so we can set it up for sine law. Okay, so we're going to move from the real world into the mathematical world. So we just have to draw a triangle. Now these are just sketches. Okay, so we have 89 degrees here, 34 degrees, 57 degrees. This is 210. And the question says, what are the lengths of the two sloping sides? So we're going to want to know how long this side is and how long that side is. Well, if we're going to use sine law, we're going to want to set this up so it starts to look like the sine law. And it really doesn't matter where you start. Sine law has sine A over A, sine B over B, and sine C over C. So let's make this triangle ABC. We'll go A, B, C. This makes this side little a. If that's angle B, opposite from that, this is side B, and we want to know what that equals. And then across from angle C, we have side C, and that's what the question wants us to find. We want to find side C and side B, the two sloping sides. Before I go any further, give this some thought. Pause the video, see what you think you'd do, and then come back. Since this question only has us finding unknown sides, we're going to use this version of the formula, where we'll put the unknown side up here and look for one ratio that's completely known to help us. So let's have a look at our diagram and see what we can use. So let's start with side C in our diagram. You could start with B. Kind of gotta see what you have. So we'll start with side C. So I want to find side C. And to do that, I'm going to write C. And let's check and see. Do I have angle C? I do. So sine C, I will use 57. Now I need to equal that to like a pair that's completely known. So is B completely known? No, we only have angle B. What about capital A for angle A and lowercase a? We do have them. So this is a really important piece. We're going to write that in the same order. So A over sine A. Okay. Now you can replace and do your calculation. So C over sine 57 degrees equals 210 over sine 89 degrees. And here's where you cross multiply. Now it's really important that you cross multiply correctly. You have to say, first off, all that's left here is C. This sine 57 degrees is multiplied by 210, but write the 210 first, because you want to write 210 times the sine of 57 degrees. You want to avoid writing sine 57 degrees times 210, because your calculator will see that and it'll think you want to do sine 57 times 210, and it'll take the sine of that number. So you want to write 210 before, okay, and this will not give us an answer we're going to want to use. Okay. And don't forget, you're still dividing that by sine 89 degrees. Okay, and if you allow your calculator to do this in one shot, it comes out with your answer. Okay, so we want 210 times sine 57, and we'll divide all that by sine 89, and we get the following: 176. And this is an application. and that is 176 meters, and that is indeed one of the sloping sides. Okay, to get the other unknown side, side B, well, you know you need to use the same style formula where you're putting the unknown side on top and the signs on the bottom. So B is unknown, and think about your sign formula. It's supposed to say sine here and the corresponding letter. Okay, but uppercase, so sine capital B. And we actually don't know this, but we do know the capital B angle of 34 degrees. Okay, so now you have to equate that to something. And I mean, you do have all the info for C now, because you just found side C and angle C, so you could write C over sine C. But I would avoid that, because who's to say your calculation here is totally correct? I would rather use A over sine A, because that was given info. And you know that given information can be trusted. You might not trust your calculation. Okay, so everything's known except for side B. Here we go. B over sine, angle B is sine 34. A is 210 over sine 89 degrees. Okay, and again, you just have to cross multiply and write it out. So B is now isolated. It equals 210. Same idea, write the number first, then multiply it by the sine of 34 degrees and divide that by sine 89. Okay, and grab your calculator and do the calculation. So 210 times sine 34. I hit equal there, that's fine. And you could even write that out. You could write 117.4305 if you want some precision. And then you would have to divide that by sine 89. And you get 117 meters. Okay, I'm just going to write it out. Just some people are doing it that way. 210 times, so 210, I wrote it down, times sine 34. Well, let's work these out individually. You can do that. Take at least 3-4 decimal places. So it's 210 times 0.559. And sine 89. 0.9998. Okay, and you're going to get the same answer that I got earlier. In fact, I'd rather you do the way you saw earlier. It's quicker, it's cleaner, you get more precision out of the calculator. Here we're losing a little bit of precision because we only took 3 or 4 decimal places, but it won't affect the overall angle answer. Okay, so try the calculator. Here we go. 210 times 0.559, oops, and then divide by 0.9998, and what do we get? 117. Okay, and there's your answer. So the iceberg is 2 sloping side lengths. So the iceberg's 2 side lengths are, okay, well, they're 176 meters and 117 meters. So that's it for this video. Bring your questions, and we'll discuss this in class, do some extra practice on this with the worksheet, and see you soon.